Hello everyone! Today we'll talk about Geographical Information Systems. So first I will give you a brief introduction, then we'll talk about some basics geographical concepts, followed by a description of tiled display, then we'll study the vector data, and finally we'll talk about the GDAL-OGR module, which we'll use in exercises and lab work for geographical information systems. So first, what's the context of geographical information systems, GIS? It's in several points. So first, geomatics, which is a crossing of geography and computer science. It consists in using computers to process, display and interact with geographical data. It is used in many fields of expertise. So first and foremost, the navigation. Think about GPS, for instance. It's used for urban planning and monitoring, and you have any application that you can think of based on computers and geographical systems that you can build and use. Such systems are based on several solutions to problems, which are storing large data sets, because the more details you need, the more data you have to store to be able to see fine-grained information about geographical data and what's their usage. You have to standardize a common language, so for instance coordinate systems and projections, and how the processing of those data is achieved. So now let's define the geographical information systems. A geographical information system is an information system designed for storing, processing, managing, and displaying any kind of geographical and spatial data. So it provides several key features, which are storage and database with dedicated inner structures. So regular database will link and index semantics of the data. Here we have to add spatial semantics, which are not in the semantics of the usual database, so you have to add spatial indexing and so on. Then we have to embed geographical and spatial algorithms into the information system, so to be able to compute distances, coordinate systems, representation and conversions, and so on. You have to provide interfaces for applications providing vector and raster representation, and other features can be thought about, but will not enter in those details today. So what are some GIS examples? If we look at the proprietary world, there is Esri, which is one of the leaders in GIS applications. There is Google Maps, Mappy, and so on. There are a lot of proprietary GIS softwares. Now on the free open source world, we have OpenStreetMap, Quantum GIS, and other systems which usually base themselves on elementary software bricks that you can combine together to build a whole GIS just suited to your own needs. So these applications are viewed mainly from the user's point of view. If you look at the infrastructures that can provide those services and systems, there are many other softwares which are hidden from the user but are critical for the systems to be able to operate. So, before going further to some of the tools, let's talk about the Open Geospatial Consortium, the OGC, which is an international industry consortium with more than 500 entities which are partnered inside this consortium. So these entities might be companies, government agencies, universities, and so on. The OGC aims at proposing geospatial interfaces standards so that the systems, the applications, the APIs are able to operate together, whatever the provider, the developer, and so on. Here are some partners of the OGC, so Atos, S3, Airbus, Min Paritech, the Eclipse Foundation, the Harvard University, the MIT, Google, and so on. So there are a lot of big names. So now that we talked about the OGC, let's talk about some of the applications and softwares we can find as we need some of those software for managing geographical information. So there is first GDAL, which is the OGC Geographical API. So it defines a lot of shapes and so on. Then we have PostGIS, which is an extension of PostgreSQL for handling geospatial data. So if you know PostgreSQL, you know everything, all the basics of this database management system. So there is this overlay which provides the geographical operations, distance computation, and so on top of Postgre database. Third software is QGIS, Quantum GIS. It's a client application in which you can display geographical data. So for instance, Worldline, which is a sub-company of Atos, use a lot Quantum GIS to check its geographical data and its GIS development with a robust application. The current version has many features, but it might be slow if you load a lot of data. However, the next version will be based on OpenGL rendering to cope with these performances problems. Then there is Map Server, which is the OGC OpenGIS Web Map Server implementation, which provides tiling. We'll go back to tiling a bit later. And finally, we have something which is more local, the libGeologic, which is a UTBM. Well, Opera is our former team name. It's now the Femto ST Disk Omni team library for handling and displaying geospatial data. So this one is directly based on OpenGL. We have 5,000 to 10,000 line of codes for the base of the project, and we use it in various projects in partnership with industry, with other research labs, and so on.